Hello everyone, welcome to today's lecture. In this lecture, I am going to explain about what is a register and what is a register transfer language. So let's start. So the first question is, what is a register? So a register is the smallest storage units built inside the processor for quick store and transfer of data and instructions necessary for the processor. So we can say that register is a temporary storage area. So when we are transferring the data or when we are providing some instruction to the computer, at that time that data is stored at the register for a small amount of time. So that is called a register. It is a small device to store the temporary data. The CPU can directly access the register for quick actions. A register is a group of flip-flops with each flip-flop capable of storing 1 bit of information. So now I hope you all are aware with what is a flip-flop. So flip-flop is also storing a state information, and the size of the flip-flop is only a 1 bit. So what happened that if we are using a flip-flop for storing the data, so at that time we required many flip-flops to store the data. So to reduce the complexity, the registers comes in, and a register is a small device which also contains a flip-flop in it. Suppose a 4-bit register, so in that there is a 4 flip-flop. So here an n-bit register has a group of n flip-flops and is capable of storing the binary information of n bits. So here we are reducing the complexity by using the registers. Yes, but the motive is same as a flip-flop to store the data. So here, as I said that suppose this is a 4-bit register. We already know that register contains flip-flops. So here a 4-bit register means it contains the 4 flip-flop, which is flip-flop 1, 2, 3 and 4. Each has a size of 1 bit, so that is why it is called the 4-bit register. Suppose the size of the register is n bit, it means there are n registers in it. So there are many flip-flops, and we are merging that flip-flop in a small one device, and that small device is called the register. Now I hope you all are clear with what is a register is. A register consists of a group of flip-flops and combinational gates. Now as I said that register contains flip-flop, but some of the registers also contains the combinational gates. Now what is the combinational gates and why we are using the combinational gates in the register? So the flip-flops holds the binary information and gate control when and how new information is transferred into a register. So it is used to get the decision so that the outputs only turn on when the correct logic sequence has been applied. So to control the data transferring process, the gates or the combinational gates are used. So various types of registers are available commonly, and the simplest register is the one that consists of only a flip-flops with no external gates. So this is the simplest register which doesn't contain any gates, but nowadays some advanced registers are there which contains multiple types of gates in it. So that is all about register. Now the next is, what is a register transfer language? So the symbolic notation used to describe the micro-operation transfers amongst registers is called the register transfer language. So this is a definition of register transfer language. So based on the definition, we can say that it is kinds of symbolic notations used to describe the micro-operations. So the question arises, what is a micro-operations? So let's understand what is a micro-operation is. So the operations executed on data stored in registers are called the micro-operations. Suppose our binary data is stored in the register, and suppose I want addition or I want a subtractions. So this kinds of operation we can perform on the data that is stored on the register. So that kind of operations are called the micro-operations. So micro-operation is an elementary operation performed on the information stored in one or more registers. It can be anything. Suppose we want to add the data of 2 registers and store it on another and store it onto another register. So that is a type of micro operation. And they have example of micro operations like shift or count, clear and load, etc. So there are many operations are available. We'll learn that micro operation in our later session. So a sequence of micro operations are performed to complete a one operations. So let's see one example. Suppose I want to add two numbers. Okay. So there are sequence of operation we need to perform in the computer to add that two number. So the first is load operation. Load the first number in a register 1. First we need to get one number, then load a second number in the register 2, perform add micro operation and store the result in the destination register. So these are the four sequence of operation we need to perform while we are performing the micro operation task. So as shown above, micro operations description is lengthy. So symbolic notation to describe the micro operations is required. So now you can see that suppose I want to say that get number 1 from register 1. So for that we need to write load first number in register 1. So this is quite long. Yes. So in replacement of that, some symbolic notations are used. Yes, so that symbolic notation language used to describe the micro operations are called the register transfer language. So you can compare this like your C language. Yes, so in C language, suppose you want to define the integer number. So for that, the data type you are using is a integer. So that is a predefined words. These are the keywords. So some keywords is defined by the C language, and by using that keywords we can write a program. Same as in the register transfer language, it provides some symbolic notations, and by using that notation we are writing the set of instructions. So that is called the register transfer language. Okay, so that is the definition of register transfer language. I hope now you are clear with what is a register transfer language. So the symbolic notation used to describe the micro operation transfer among the register is called the register transfer language. Suppose I said that there are two registers and the data is transferred from register 1 to register 2 or register 1 to register 3. So to describe these types of transactions, this type of data transfer, the symbolic notation is used, and that is called register transfer language. So now the register transfer language is a term made up with two keywords. First is a register transfer and second is a language. So the register transfer means the availability of hardware logic circuits that can perform a stated micro operations and transfer the results of the operations to the same or another register. So register transfer means some operations or some micro operations are performed and the data is transferred, or the result of that operation is transferred to the same register or the another register. Means we are transferring the data from one register to the another register or in the same register. So that is called a register transfer. And the next keyword is a language. So the word language is borrowed from the programmers who apply these terms to the programming languages. The programming language is a procedure for writing the symbols to specify a given conceptual process. So as I said that programming language provides some keywords, and by using that keywords we are writing the program. Same as the register transfer language provides some symbols to us, and we are using that symbols to write the data transfer between the data transfer process between the registers. So that is the concept behind the register transfer language. Now in a computer system, data transfer takes place between processor registers and memory, and between processor registers and input-output systems. So the data transfer is mostly in between processor register to memory, or in between processor register to any input-output devices. So the data transfer can be represented by some standard notations given below. So now as I said that this is the language which provides the symbols to us. So these are the symbols. So the notation R0, R1, R2 up to Rn is the notation to represent the processor registers. Suppose we want to define one register, so we can define it with the symbol R0 or R1 or Rn. The second is the addresses of the memory locations are represented by names such as loc, place, mem, etc. So these are the keywords to represent the memory addresses. Next are the input-output registers are represented by the names such as data in or data out. For input or output registers, it is represented in data in or data out symbols. The content of register or memory location is denoted by placing a square brackets around the name of the register or memory location. So we can use a square bracket for the content of the register. So these are the symbols which is defined by the register transfer language. We are using the symbols for a register transfer. So now that is all about register transfer language. Now next is a register transfer. So how data is transferred and how we can define in the symbolic form. So information transfer from one register to another is designated in symbolic form by means of replacement operator. So here R1 and R2 are the two registers. Now we already know registers is defined with the R notation. So here there are two registers, R1 and R2. Now this is one symbol. It denotes the transfer of data from register 1 to register 2. So here register 1 are transferring data to register 2. So how we can remember this? So here this is one arrow. So this arrow point defines that the data is transferring to register 2. So suppose here it is R3 and R1. Suppose it is written like R3 and R1 and arrows is something like this. So we can say that the data is transferred from register R1 to register R3. Okay, so now hope you are clear. Normally we want to transfer to occur only in a predetermined conditions only. This can be shown by following if-then statement. Suppose if p equals to 1, then transfer the data of R1 to R2. Yes, we need every time if we are transferring any data from registers, so it is based on some conditions that in that condition only our data of a register can be transferred. So that condition, and to define this condition, some variable is used, and here p equals to 1. So in that, p is a control signal generated in the control section. So let's understand this. So this is called the control function. So the control function is a boolean variable that is equals to 1 or 0, and the control function is represented like p colon R2 R1. So here the data is transferred from register 1 to register 2 only when p equals to 1. Yes, so if the value of p equals to 1, it means we can transfer the data from R1 to R2, otherwise not. So the control condition is terminated with a colon. So we need to write this p colon and then register instruction. So it shows that transfer of operation can be executed only if p equals to 1. So here we are providing some control function which controls the execution. That is why here p is called the control function, which controls the execution in the register. So this is all about the register transfer language. So in this video we have seen that what is a register. So register is a smallest storage unit. It is also called the temporary storage area, and it consists with the flip-flops and logical gates. Next we have seen what is a register transfer language. So register transfer language is just a symbolic notation to represent the micro-operation. So for that we have also learned what is a micro-operations, and we have also seen the different standard notation given by the register transfer language, and also we have seen register transfer, how we can represent it in the symbolic form, and at last we have seen what is a control function, how it controls the data transfer or the register transfer. So that's it. Thank you so much for watching this video.